All right, ladies and gentlemen, welcome to the video notes for Chapter 8, Section 5, Elevation, or Angles of Elevation and Depression in your McGraw-Hill Geometry textbook. This video series will consist of 3 videos, 2 for regular geometry and 1 for the pre-AP geometry that covers some harder examples. What we're looking at here in Section 8-5 are word problems for SOHCAHTOA. And they come in 2 formats. So let's go through those formats here in this first video, and then we'll do a couple examples. Then we'll have a second video that contains a couple more examples, and a third video for the pre-AP students that contains the harder examples. So, vocabulary-wise, we're talking about angles of elevation first. The angle of elevation is the angle formed by a horizontal line See, my pen is working so well today. Let's try this again. Horizontal line. And a line of sight to an object located above the ground. So in other words, what I'm talking about here is we have this object, which would be up here somewhere. We have, here is the point of view that we're working with. Okay, and they form a right triangle if we break them down into vertical and horizontal pieces. Essentially, we've got this horizontal line. Okay, that could be the ground. It might be eye level. It just depends on the problem. And we've got a line of sight for our hypotenuse. So the angle of elevation is the angle between those 2 lines. So in this case, I'm labeling that with the Greek letter theta, which it's just a variable. If that bothers you, use an x, use an a, use a b. It doesn't matter. It's just a variable. In higher mathematics, we do use Greek letters to represent known angle measures. So when we don't know an angle, we use a Greek letter for our variable. That is the Greek letter, again, theta, T-H-E-T-A. Theta here is marking the angle of elevation. Okay? It will always be that picture. Every single time your word problem contains angle of elevation, that would be the picture you would start with. The other type is angle of depression. Very similar to angle of elevation. What changes about the picture is the point of view. The angle of depression is the angle formed by a horizontal line above the ground and a line of sight to an object that is on the ground. Okay, so this time this dotted line is representing our horizontal. And instead of our object being up here, this is now our point of view. The object instead would be below where we are viewing it from, which still leaves the line of sight as our hypotenuse. So the angle of depression, which again I'm going to label with theta, is between that dotted line and the hypotenuse. Now, one thing to keep in mind is that in this case, the horizontal dotted line is parallel to the horizontal line on the bottom of the triangle. And because of that, the angle of depression and this acute angle in the triangle here must be congruent. Okay, this angle must be congruent to the angle of depression. The reason for that is because this angle that I've just marked in red with theta and the angle of depression, well, the hypotenuse is the transversal of a pair of parallel lines, which makes those 2 angles alternate interior angles. And according to the alternate interior angle theorem, any time that a pair of parallel lines is cut by a transversal, like the hypotenuse, alternate interior angles must be congruent. So again, this is the other type. So every time the word problem says angle of depression, we would start with this picture. Okay? All right. So we're going to do a couple of examples here to illustrate how to do these problems. This first video here will cover the angle of elevation examples, and then I will start a second video for the angle of depression simple examples, and there will be one final video for the advanced problems. So The example reads, and this is always a key, we always read the problem first. Leah wants to see a castle in an amusement park. She sights the top of the castle at an angle of elevation of 38 degrees. She knows that the castle is 190 feet tall. If Leah's eyes are 5.5 feet above ground, how far is she from the castle to the nearest foot? So, again, the key words here are, this is an angle of elevation problem. That means that we draw the angle of elevation picture, which is just a right triangle. And this angle down here would be our angle of elevation, 38 degrees. Now, there is a little bit more to this problem because that is not ground level, that is Leah's eyes. So I'm going to get a little bit fancy here, but you do not need to. Okay, she's looking at this castle. So here's the castle. I know, my art is just brilliant. I'm such a great artiste. But anyway, there is the top of the castle is up here, and actually that's not great. Let's clean that up and make it better. Okay, the castle, the top of the castle is right there at the top of our triangle. Okay, we know that that castle is 190 feet tall. Now the last bit of information is that this distance here from Leah's eyes to the ground is 5.5 feet. Now the reason why that is important is because we're not going to use the 190 in this problem. We need to use this distance right here from Leah's eyes to the top of the castle. And the way that we would find that is we would take the 190 and subtract 5.5 feet, meaning that that is 184.5 feet. We are asked to find out how far Leah is from the castle, which would be the length of the horizontal side of that triangle. So if we remove all the bells and whistles, what we're looking at here is a right triangle with a 38 degree acute angle. The adjacent side is what we're trying to find, x, and the opposite side is 184.5 feet. Okay? So again, like any other SOHCAHTOA problem, what we do is based on the angle we're working with, we name the two sides we're working with, just like we did in section 8.4. 184.5 is the opposite side, and x is representing the adjacent side. Then we look at SOHCAHTOA, not because we have to figure out, an exact sine or cosine or tangent value, but because we need to set up the correct equation. Because we're working with opposite and adjacent, we want to choose the trig function that relates opposite to adjacent. This is a tangent problem. Then we write an equation. The tangent of our angle, 38 degrees, equals opposite over adjacent, 184.5 over x. Now we've solved dozens of these in the last few days, so we should know that when the x is in the denominator, we need to multiply each side of that equation by x to get x out of the denominator. That will transform the equation into x times the tangent of 38 degrees equals 184.5. Then, to get x by itself, we divide by the tangent of 38 degrees. That would give us that x is equal to 184.5 divided by the tangent of 38 degrees. We're going to enter that into our calculator. 184.5 divided by the tangent of 38 degrees. That is 236.1. Okay, and we're looking at that 0.1 because we're supposed to round to the nearest foot in this problem. Okay, so that 1 tells us that we're going to round our answer down to 236. 236 feet. Now the final little bit of the puzzle is that this is a word problem, so remember that I expect you to give a word answer. It says, how far is she from the castle to the nearest foot? We would say Leah is about, because we rounded, 236 feet from the castle. So there is one example of angle of elevation. Let's do another one. Actually, what would be better is if you pause the video and try the next example on your own, then resume the video and see how you did. All right, once again, whenever we start one of these problems, the first thing we should do is read it. So we have here, the crossbar of a goalpost is 10 feet high. If a field goal attempt is made 25 yards from the base of the goalpost and clears the bar by 1 foot, what is the smallest angle of elevation at which the ball could have been kicked to the nearest degree? So again, we look for those key words. Angle of elevation, that's how we know this is an angle of elevation problem. So we're going to be starting off with our basic angle of elevation picture. Now I'm going to get fancy again just because not everybody knows what goalposts are. So goalposts are the things in football where we're kicking the ball through them. Okay? So they look kind of like this. Okay? What we're saying is that that football is being kicked through those uprights. It is clearing those uprights by 1 foot. The uprights themselves are 10 feet high. We've got our right angle right there, and we're asking what is the angle of elevation if we are 25 yards away from the base of the goalpost. Now, a couple of things. One, we cannot do this problem with one measurement in feet and the other measurement in yards. So what we have to think to ourselves is that 1 yard is equal to 3 feet, and we have to then take 25 times 3 is 75 feet. Okay, we need both measurements in the same unit. So again, we take away all the bells and whistles here, and what we're looking at is a right triangle with a height of 11 feet, a base of 75 feet, and we're being asked to find this acute angle at the base. So just like all the other SOHCAHTOA problems that we have done, we need to figure out whether this is a sine, a cosine, or a tangent problem. Now I will say that we tend to use tangent a lot more often in these types of problems than we do sine or cosine, but it is not a foregone conclusion that it will always be tangent, so you've got to be sure that you check. Name the two sides that we're working with. That would be the opposite and the adjacent. Look at your options. Sine is opposite over hypotenuse. We don't know hypotenuse. Cosine is adjacent over hypotenuse. We don't know hypotenuse. This, again, is a tangent problem because tangent is opposite over adjacent. Set up your equation. Tangent of x equals 11 over 75. Remember that I do expect to see that equation. You are not showing enough work if you never write the equation. Then, we need to solve that equation for x. So to get x by itself, we need to get x out of the tangent function, which means we need an inverse tangent function, or an arctangent. Again, I would not expect to see this work step, but these are your notes, so it's probably a good idea to write down what's going on. What we're going to do is we're going to take the arctangent, or tangent to the negative first power, inverse tangent, of each side of that equation. When we do that, tangent will undo arctangent. They'll cancel each other out. And we'll be left with x is the arctangent of 11 over 75. So we're going to feed that to our calculator. We're going to hit second tangent, and in the parentheses, we're going to type 11 divided by 75. That is approximately 8.3. Again, I'm looking at that 0.3 because we are told to round to the nearest degree. So 3 tells us to round down, and that x is going to be approximately 8 degrees. So we would say, in words, the smallest angle of elevation would be about 8 degrees. Okay, so that's going to do it for our first video. We're going to have, again, 2 additional videos. The next one will show examples of angle of depression. And the final video will show the more advanced problems, one hard and one medium, problem on how this could get harder. So again, this next video will also be part of the regular geometry playlist, and then the third and final video, well, it won't be on this playlist. It'll only be on the honors or pre-AP list. Thank you very much for your time and attention. I look forward to you watching the second video.